The first lesson in Chapter 7 deals with operations on functions. Today we're going to add, subtract, multiply, divide, and do compositions of functions. It's really not too tough, but it is just the first lesson as well. And of course, that's a sunfish. So we're going to start with addition and subtraction. Of course, up here at the top we've got f of x equals x squared minus 3x plus 1, and g of x equals 4x plus 5. Those are our two functions. Really, we only care about that right side. F of x and g of x just kind of name the functions for us. We don't need that left side. F plus g of x just means we're taking x squared minus 3x plus 1 and adding it to g, 4x plus 5. We've been doing this since Algebra 1. We're just combining like terms. So we get x squared plus x plus 6, and that's our answer. Not too tough. For subtraction, same process. F minus g of x, it just means we're taking x squared minus 3x plus 1 and subtracting 4x plus 5. Remember, I don't like to deal with subtraction if I don't have to. One way you can do this is by changing this to addition and then changing all the signs behind it. Once you've done that, combine like terms. X squared minus 7x minus 4, and you've got your answer. Not too tough. And the fish, of course, is a crappie. So the next thing we're going to do is we're going to deal with multiplication and division. You notice we still have those same two functions, f of x and g of x. For multiplying, x squared minus 3x plus 1 is multiplied by 4x plus 5. You can do superfoiling where you distribute those and those and those. Some people prefer box method, but you'd set up like this. Use whatever way makes the most sense to you. 4x and x squared is 4x cubed. 4x minus 3 or negative 3x is negative 12x. 4x and 1 is 4x. X squared times 5 is 5x squared. 5 times negative 3x is negative 15x. And 5 times 1 is 5. When we combine our like terms, we get 4x cubed minus 7x squared minus 11x plus 5. Multiplying them like you've multiplied polynomials before, not too tough. Division is actually easier, which is strange because normally division is tougher, but division in this case, so easy. We have f divided by g of x. So we put f on top, x squared minus 3x plus 1. We put g on the bottom, 4x plus 5. And there's one rule in algebra that we always have: we cannot divide by 0. So we know that 4x plus 5 cannot equal 0. We do some quick solving, getting x by itself. 4x equals negative 5, divide by 4. So x cannot equal 5/4, because when x equals negative 5/4, that's when the bottom equals 0. So your answer for these division ones, you just write it like this, and then you make the little note, by the way, x can't be 5/4 negative. That's your answer. Not too bad. The picture is of a bass, and I'm still unsure whether this is of a girl or a guy. The last type of problem we're going to do is composition of functions. It's putting those two polynomials together. Composition of functions, they're written one of two ways. Either like this, and it's read the composition of f of g of x, or it's written like this. These two are the same thing. I've had students in the past call these fog problems because it looks like FOG, but it's really like a degree sign but in the middle. The key to these is you're going to start on the inside and work your way out, kind of like eating an Oreo. You start with that creamy filling before you work your way out to those average cookies on the sides. So, f of g of 2. Another way the book might write this is f of g of 2 like that. We're going to start with this inside part, g of 2. All that means is we're going to take 2 and plug it in for x in that g function. So 4 times 2 plus 5, 4 times 2 is 8, plus 5 is 13. That's what g of 2 is. Now that we've done that part, we take this number and work our way up, plug it into f. So that means we now have 13 squared minus 3 times 13 plus 1. 13 squared is 169 minus 39 plus 1. 169 minus 39 is 130 plus 1 is 131. And so your answer is 131. You start by plugging 2 into g. Whatever you get is your answer. You plug that into f, and your answer is 131. On this other side, we have g of f of 2. Again, we start on the inside with f of 2. So we're taking 2 and plugging it in. 2 squared minus 3 times 2 plus 1. We get 4 minus 6 plus 1, negative 2 plus 1, or negative 1. And then we take that answer, work our way out, plugging it into g. So we get 4 times negative 1 plus 5. 4 times negative 1 is negative 4, plus 5 is 1. So that is actually our final answer. We start with f of 2, plug 2 into the f function. Whatever our answer is, we plug into the g function, and we get 1. Not a big deal. And of course, because our book hates us just a little bit, it gives us ones to do that do not have numbers in them, like g of f of x. What we do for this one, I tend to rewrite it because g of f of x written like that seems to make more sense in my head. What we're going to do is we're going to take the function f of x and plug it into g of x. So I'm taking the whole function, x squared minus 3x plus 1, and I'm plugging it in to the other function. So I get 4 times that whole function, x squared minus 3x plus 1, plus 5. 4x plus 5. What I do from here is I distribute and simplify. 4x squared minus 12x plus 1, no, plus 4, just kidding, plus 5. Combine like terms, I get 4x squared minus 12x plus 9. And that would be my answer. Not nearly as easy when you just get as when you just get a number, but there'll be problems like this in your assignment. And of course, the picture on this one, you can tell by the white tail, the white tip on the tail, it's a walleye. All right, with this last slide that we have, it's still compositions of functions. It's a little bit different because we have a set of relations instead of equations. But most students find this simpler than the other way. So we're going to find g of f, the composition of g and f, and the composition of f of g. Remember, if it helps to rewrite it, with parentheses, rewrite it. We're going to start with f, And then after that, we're going to plug into G. Remember, we start with the middle. So what we're going to do is we're going to take a number, plug it into F. What gets spit out of F, we're going to put into G. And our answer will be spit out from there. Our answer is actually going to be an ordered pair. Move these down so it's a little bit easier to see visually. If we take a 1 and put it into F, it's going to spit out a 2. We take that 2, put it into G, it's going to spit out a 2. So my answer is the ordered pair 1, because I put that in up top, and 2, because that's what I got out at the bottom. We'll do another one. We put in a 2 up here. The F function gives us a 4. We put that 4 into the G function, and it spits out a 1. So my answer is the ordered pair 2 that I put into initially, and the 1 that I got out at the end. When I put a 3 into F, it spits out a 3. When I put that 3 into G, it spits out a 4. So my answer is the ordered pair 3, 4. And finally, when I put a 4 in to F, it gives me a 1. When I put that 1 into G, it gives me a 3. So my answer is the ordered pair 4, 3. Put curly brackets around that, commas in between your sets of points, and that's your answer. If we were to do things the other way, f of g of x, the composition of f of g, you'd just go backwards. You put into g first, and then into f. So if I erase this and switch these around, we can do that one as well. Again, we're going to put G in first, and then spit out F. Put a 1 in, goes to 3. 3 goes to 3, spits out a 3. We get 1, 3. We put in a 2, goes to 2. Put in 2, it spits out a 4. We get the ordered pair 1, 4. If we put in a 3, gives us a 4. Put that 4 in, gives us a 1. So our ordered pair is 3, 1. And finally, 4 gives us a 1. 1 gives us a 2. So our last ordered pair is 4, 2. Just kidding, I did that one wrong. Curly brackets, separated by a comma, and you're all set. Here's your assignment that we'll work on during class tomorrow. And that's all, lesson 1.